The NPV function is quite useful and it can substitute in some situations for the present value, but in most scenarios we end up finding that the present value is the most direct way to go. The first thing to point out is that the syntax of the NPV function shows us how the NPV function is used. Some people have commonly been dissatisfied with the NPV function and say, oh, there's an inherent error in the NPV function, but this is not so. It's just individuals using the NPV function fail to look at the syntax and the arguments of the NPV function. So let's start out by typing =NPV, and of course that stands for net present value. And what you see is when you look at the syntax, we have NPV, we have rate, and then we have values. And notice it says value 1, possibly value 2, ... And what this tells us is we're starting at value 1. And some people think, well, this should also include value 0. It does not. So whenever introducing time values and using the net present value function, remember NPV is for starting at value 1 or time 1, not time 0. So this becomes an important point. Some people are unhappy that it starts at time 1, but this is just how the function is designed. Again, we can click on NPV to go to the help, and we can scroll down to the calculation and get an explanation for starting at time 1 versus time 0. So we can find the present value of a lump sum or a series of cash flows, and we can find the value of an investment with cash flows. So again, note, NPV starts with value 1. A value at time 0 is not recognized, so you have to add anything at time 0 back in. So our first setup is we have an annuity that pays $100 for 5 years with a discount rate of 5%. What is it worth today? So we want to know, what is it worth at time 0? So we just simply can type in =NPV. We indicate the rate, and then we simply add or capture all of the values that we want to reference. And again, Excel recognizes the first value at time 1. If we had a 0 value at time 1, we'd have to, of course, start with 0 and then get the added cash flows. We can see that there is a net present value of $4,329.48 for this annuity. Again, we can also use the PV function. We have rate, number of periods. We can reference one of the payments for the annuity. The future value, there's no lump sum in the future, so we type in 0. And the payments at the end, so we can leave it blank. But just as a measure of good form, we're going to type in 0. We can say that we get the same value, so it works just the same. So you be the judge. In this example, which one's easier, NPV or PV? The second example, what is the present value of a project that requires an initial investment of $100,000 and a rate of return of 8% and provides the following cash flows? So what we're saying is we make an initial investment at time 0 of $100,000. We have a series of cash flows that are cash inflows at time 1 moving forward. And on the initial $100,000 investment, we require a rate of return of 8%. So what are these cash flows worth today? So we start with =NPV. We type in the rate. Now again, remember, NPV starts at value 1. So in order to solve for the NPV, we're going to select the cash flows from years 1 through 5, close the parenthesis, but then to account for the cash outflow at time 0, we are going to add the initial investment, which is a cash outflow. If this cash outflow wasn't shown as a negative, we would then subtract it, but it's properly referenced as a cash outflow at time 0, so we add it back in. We can see that this investment improves our wealth by $3,496.38. So this is a project we would consider investing in because it adds value. That is, if we started with 100,000 times 0, by taking on this investment, we're $3,496.38 better off. In the last example, we can find the value of a lump sum for this received in 5 years from now. That is, we have a future value. Okay, so we want to see, can we find out? What we end up finding out is that the present value function is better, but let's just use the NPV to find out. So we'll say NPV, and we need a rate. So technically we don't have a rate given. Let's just select a rate of 8%, and we want to see what this future value is worth. Now note, because we're not receiving this amount till year 5, we have to have 0 values for years 1 through 4. If we just selected 25,000, Excel would view this 25,000 as occurring at time 1, not time 5. So we can see that this 25,000 received 5 years from now with a discount rate of 8% has a present value of $17,014.58. If we use the present value function, we can enter our future value of 25,000, and we get the same amount. So again, it's up to you which one you want to use. I wanted to show you that there's more than one function to solve the same question. In some examples, PV might be more efficient. In other examples, NPV.